I have the pointer. Very small hands. Maybe I can use it to like. Yeah. Cool. All right. Well, Colin's getting set up. How many people here like deploying code? How many people think it's terrifying? Yeah. How many people feel confident when they deploy code? Okay, cool. I was just curious because I find it can be very scary, and that's kind of why I wanted to give this talk, because there's a lot of things you can do to improve that process. Yeah. So a little bit about me. This is my GitHub handle, GwinCR11. I am originally from Wisconsin. I lived in California for a while, and I currently live here in Pittsburgh. I'm a software engineer at GitHub. I've been programming since I was 14 years old, and I didn't go to school for this. I taught myself. I've been programming professionally for 15 years in Ruby, Python, JavaScript. As a front-end developer for a while, I did some Elixir. I've done plenty of PHP. I've done front-end and back-end work. I like bikes, soccer, cooking, programming, and reading when I have time. This is my son, Nevin, and I am the parent of 2. Yeah, so that's a little bit about me. So today we're going to talk about deploys. There's a lot of different kinds of deploys. There's bug fixes. There's incidental things that don't really scare anyone or break anything. There's bigger things like feature improvements or releases, database schema changes, and rollbacks when things go wrong. We're going to touch on pretty much all of these. So what makes code releases so scary? There's a lot of categorical problems that can occur when you're deploying code for the first time. I work at GitHub, so scaling problems are very real for us. You can introduce errors. You could introduce a confusing interaction that people don't understand. It's hard to change data on the fly. You could deploy something that misses requirements. You might have multiple releases that affect each other. And then there's the question of when is it safe to actually merge this into master? So challenge accepted. We are going to go on a whirlwind tour tonight. We're going to talk about philosophical things, cultural things. We're going to talk about tools, and we're going to explore kind of like the start of when you code all the way to when something is out in the wild and what that life cycle can look like. So this is a fairly large talk. When I first started putting it together, I thought I had a pretty good idea of what it was going to be. And then I was working on it, it just continued to get bigger and bigger and bigger. And I actually having put this talk together, I'm like, wow, I could really rip this out and turn it into a whole series of talks. So there's not a whole lot of depth in some of this stuff. So if you guys have questions, let me know. The other caveat to this talk is there's a ton of tools out there. I can guarantee that every one of you is on a different tool chain. I'm not going to weigh in too much on tools because those are really dependent on the stack that you're on and your preferences. I'm going to talk about things a little bit more categorically, as opposed to saying you should use X or Z. I'm going to talk about the categories of tools that you should be using and where they fit into your pipeline. And I'm going to try to do some live deployment and see if it fails on me or not. Fingers crossed. Okay, cool. So we're going to take a tour of the good ideas that I've experienced. So these are based on a number of places. I know in all of the things that you've seen, it said GitHub. But these are also things that are culminating from other places that I've worked. So early in my career, I helped build 105 large news websites, including 16 for NBC Universal. I worked on a video streaming service and a content management system. I worked on a DARPA project. I worked with a multinational bike conglomerate, and then worked with a ThoughtBot startup, and now I'm at GitHub. So this is kind of a culmination of things that I've seen at a lot of places that have quote-unquote good development practices. So I'm trying to kind of pull pieces from different places and tell you what I've seen that's consistent and that works well. So the first thing I'm going to talk about, since I do work at GitHub, I am going to promote Git Flow. How many people here are familiar with Git Flow? A few of you? Okay. So um, this is actually a really good resource to talk about what Git Flow is. Let's just pull it up really quick. Git Flow is basically this idea of how you go through and work on code using Git. So you start out with a branch. You add commits to your branch. You open a pull request. You discuss your pull request. You deploy your code. And then eventually you merge your code, right? So that's kind of the standard Git flow. And it's not necessarily limited to Git. You could use it in other version control systems as well. But that's just the name that we use because it's associated with Git. Okay, so that's kind of like the prerequisite of this entire talk is we're going to be talking about how deployments look inside of Git Flow. I'm a Git proponent. I've used Subversion. I clearly work at GitHub, so I have a preference. But inside of the GitHub world, everything starts with a PR, right? So you started your work, you have some sort of a feature that you're implementing, and you're starting to write some code, and you open a PR. So the question is, like, what are the goals of a PR? The goals of a PR are to have a consistent way to propose and implement changes, have a clear review cycle, have a long-running history, enforce common rules, follow the Git flow, and use version control for testing different versions and environments. This is kind of the overall framework for like what a pull request enables you to do, right? And each one of these bullet points and goals like have ways and tools to implement each one. So we're going to start with talking about PR reviews. So the first thing to recognize with a PR review is that you're on your own branch or fork. You never want to commit directly to master. If you're in GitHub, there's actually a way that you can lock down a branch so that you can't commit to it. So that's like one of the first things to do is to like lock down that branch and make sure that no one can just commit directly to it. You want to review as early as possible and as often as possible. It's always awful to like have the swoop and poop happen where you've been working on something for a really long time and all of a sudden someone just swoops in out of nowhere and poops all over everything that you've done and then runs away. This is kind of the worst possible situation. So try to get those reviews in as soon as possible. And try to like, when you're writing a PR, it's important to kind of let people know what state it's in, right? So I like to use things like to-do lists. I like to mark them as works in progress. And just kind of keep track in a very visual place of where you are in the process so that when reviewers come in to look at what you're doing, they have a frame of reference of like what they should be reviewing at that point in time. If you have 5 to-dos left and a work in progress label, someone's going to review it very differently than if they think it's a final product. I'm not sure how many people are familiar with this, but there is a setting inside of GitHub called code owners. That lets you specify using like a very special syntax who owns what types of files inside of a code repository. So you can say this team is in charge of JavaScript files or this team is in charge of database migrations. And you can kind of base it off of folders and you can base it off of file names. And there's like different sort of regexy checks that you can do. And so when you open a PR, it checks which files in that PR have been altered, and then it requires reviews from those people and notifies them that work is being done on code that they own. So if you do have like very specific rules about who should review what code, code owners is a really good tool to use for that. Lockmaster until all requirements are met. So also inside of GitHub, there is the ability to really kind of lock down what happens inside of a specific branch. Of course, this user doesn't. I'm sorry, I set up a test user because I can't show you my GitHub user because I have all kinds of things that you don't know exist. And this user doesn't have access to what I need. But in a PR or in a any sort of repo, there's a security section, and you can set rules for like a branch merge. So you can say must meet code owner's file, must have 3 reviews. This CI check must pass before we can merge. So you can set all those sorts of very specific rules on master or whatever you want. Also use bots to check PRs. I'm going to talk about bots a little bit more later, but this is something that can really help to automate a lot of your workflows. All right, so the first thing we're going to talk about then is testing in CI. How many people here write tests? About half, a little more? Okay, cool. So testing is your first line of defense. You know, you're protecting your code against regressions. You're ensuring that things continue to operate in the expected manner. They tell other teams how your code works. Someone this weekend at Code Retreat said that testing should be your documentation. I have feelings about that, but I think that it can be true. A lot of times I will look at how tests are written in order to understand how a piece of code works. So testing serves multiple purposes. It ensures that code continues to function in the way that you want, but it also kind of gives you a tool to look at to see how code works. So testing in CI. Who knows what CI is? Okay, so CI is continuous integration. Sometimes you'll see these words coupled, continuous integration and continuous deployment. So this is the idea that you have a test suite. When you push to GitHub or whatever your flavor of the week is, and you open a PR, your CI should run, and it should test all that code to ensure that it meets the quality standards that you're expecting. And you don't let code go out the door until all those tests pass, right? Continuous delivery is kind of like a step beyond that, where some people go so far with this culture that if the tests pass, they deploy. I've worked in this sort of scenario. I'm not a huge proponent of continuous delivery. It's okay with small teams and small sites. I think it runs into problems when you have bigger teams, and I'll talk about why I think that later. It can be okay in certain environments like lab environments or testing environments. And I think it can be okay if you're merging into master and you've already tested your code, but you need to be careful about where you do it. All right, so continuing along with this, if you are following this CI path, you should always include tests with every change. One of my coworkers always says, like, what tests can I write to feel more confident about this code going out? And before he pushes any PR, he always asks that question and implements that one more test. Testing is kind of a personal thing. How you like to write tests is different for everyone. I like to write integration tests first, which are very high-level tests, and then I build down. Some people build up. It doesn't really matter how you write tests. What matters is that you're doing it. And then you also want to check for test coverage. So there's these tools that can do static analysis of your code base. So they run your test suite and they check the paths of the line of code, and they tell you how much of your code base is covered with tests, right? So they'll say that you've tested 100% of your code base, or you've tested 50% of your code base. And so what we do is we set up these test coverage checks, and we ensure that they don't go down, they only go up. And as far as testing in CI goes, like, every person that you're going to talk to is going to have a different opinion. Everyone's going to think that their way is the best way. The important thing isn't that someone's way is better than someone else's way. The important thing is that you're confident and comfortable with the code that you're deploying, and that you're doing the best that you can to continue to improve that situation. All right, automating things. Automate all the things. we're going to talk about different ways that you can automate stuff inside of GitHub. So you see a few things here. Here we have a bunch of CI tests. Here we have some GitHub Actions running. I don't know, how many people here know what GitHub Actions is? Yeah, it's only been like globally available for a week now, but we're going to talk about this a little bit. And then this is a tool that I'm going to talk about called ProBot. Who knows what ProBot is? Okay, cool. Just getting some groundwork here. Okay, so again, coming back to kind of our list of things to do, you want to run your test suites on every PR push. You want to run your code linters and static analysis on every push. You want to use actions to build and test against different environments. We're going to talk about what actions are in a little bit. You can use actions to deploy in a sandbox. We're going to talk about that a little bit more too. And then automate what you can for security checks, schema alerts, and other needs. So ProBot is a tool that we open source. And what it is it's a little bot that you can host like on Heroku or something, and it hooks up to webhooks. And every time that you open a PR or push to a PR, ProBot receives the PR change notice, and then ProBot can go in to that code and look at what you did, right? So we have lots of scripts that will go through and look at what files have changed and look at the code that's changed. And we write like little regex checks or little scripts that look for suspicious looking changes, and then have ProBot leave comments or add reviewers to issues automatically. So for example, you can use this if you have like a known best practice about how database migration should work. You could say, hey, you're adding a database migration, and you could have ProBot go in and flag it, add a comment, and notify your database team that a migration has been added to this code base and they need to look at it and review it. Or you could have it go in and notice like some sort of security thing that you know is like a known issue for your company. So if you have like a line of code that is, you know, very private and shouldn't be leaked, you could have it check for that. Basically, anything that you can script, ProBot can check for and leave a comment or a message. You can also do this sort of thing with GitHub Actions, but ProBot's kind of made to do it. 6 of one, half dozen of another. It's kind of up to you. And then you can also use GitHub Actions for a lot of things. We're going to look at application that I made and how to deploy it with actions in a little bit. This example deploy application right here is where my slides are, and it's also where this app is and all the workflow files for GitHub Actions. So if this stuff stems your interest tonight and you want to dig into it, everything is in this repo, so you can go through and check all of it out. Grab a drink of water. Okay, let's talk about deploying a little bit. So when you're deploying, you're going to be deploying to an audience. So it's always safer to limit your impact when you're deploying something big, and be able to toggle the availability of that thing. So like the idea of beta testing comes to mind. I don't know how many people here have practices around beta testing? Ish. Okay, cool. So let's talk about feature flags. So feature flag is basically you wrap your new code in like a check, and then you give that feature flag a name. And we use Flipper. Jane Noonmaker is a GitHub employee, and he wrote Flipper as an open source project. This is a Ruby on Rails project that lets you basically put your new code inside of a conditional check. And then we have a little UI where you can go in and you can specify who can access it by username or by team. We can set it to a certain percentage. And then Flipper can keep track of like who has access to what, and either give them the new feature or not when the page loads. Or if it's like a bot, when they make a request. Basically, any kind of response, we just check to see who it is and either show it to them or not. This is a great way to beta something because you can limit who your audience is, and you can also slowly increase the footprint of something and control who all it goes to, which lets you deploy to a safe group of people, check for errors, check for user problems, and learn without actually impacting your GA audience. Acronym, who knows what GA is? Okay, global audience. You want to try to find a way to make it easy to toggle this via UI. There are companies out there that sell feature flagging tools. Can't think of the name of the chip. Darkly, I think is Launch Darkly. Yes, they will sell you this tool so that you can do it in multiple code bases. If you're in Rails, you can just use our open source project for free. The next thing to look at is experiments. So not necessarily everything is like feature flag worthy. Sometimes you actually want to get some metrics, right? So feature flags are really good when you want to like push something out the door and test it with a group of people and get feedback that is more qualitative and less quantitative. We have a tool called GitHub Scientist, and we have this in Ruby and in Go. And what this does is it lets you write two pieces of code, your old code and your new code, and wrap them inside of what's called an experiment. And then specify like how much of the audience gets each version of the experiment, and then collects data, and we send it back to our StatsD Grafana dashboards. But there's also a console tool as well. But if you want to put something out the door and see how it affects site performance and not ship to your global audience and slowly increase the size of your experiment, this is a really good way to do it. We have a UI in front of this as well that lets us see all the experiments that are running and slowly increase the percentage via UI or decrease the percentage of UI, so we don't have to actually deploy code. We can toggle it in a UI. Yeah, so really two different ways to test out new code: feature flagging and experiments that have very different kind of needs. And yeah, if you're using Ruby Scientist, if you're using Go, I think it's Go Scientist. Okay, let's talk about actually hitting the big time. So again, automation is super important. Did all your tests pass? Did all your linters pass? Have the required reviews been completed? And is the PR up to date with master? All of these things are checks that you can put into that settings area in GitHub where you say, guard this branch from having this happen. And there's a piece of GitHub called the deploy API, which we're going to look at in a little bit. And the way that I'm going to suggest that you deploy is that you hit that deploy API. And what happens is you pass a message to that deploy API saying, I want to deploy this branch. And it will check all of your required things and say whether or not you can deploy based on your settings inside of GitHub. Clearly, I want you all to use GitHub. Cool. The other thing to consider is a queue. So we deploy a lot, like a lot, hundreds of times a day. It's kind of constant, and we have this thing called training, where like if you want to deploy, you get on a train with other people, and they merge all of the PRs together into one giant PR, and then the train gets shipped out together. So we're deploying probably thousands of PRs a day now. I don't even know. But when you're doing things at that kind of scale, queuing becomes a problem. I don't know, probably not many of you are dealing with that kind of deployment scale, but it's something that you need to think about if you do hit it. I'm not going to go into it too much because I don't think it's everybody's use case, but if you're interested in it, I know that there's some good write-ups by Etsy about how they train and deploy, and those are definitely worth looking into. When you're doing things at that kind of scale, like the things to think about is how much time are these deployments out for, like automated tools to check if exceptions have increased, automated tools to see if there's been any sort of performance hit with any of these deploys, and then a way to like visually tie the exceptions or the performance problems to a specific PR. And then putting people in a line and being like, wait your turn. Because all that stuff takes time. Also, having different environments is important. So we have multiple environments. We have a lab, which is, I don't know how many people have seen it, but Heroku has this thing where you can have Heroku automatically deploy for every PR that you open. So you open a PR in GitHub, and Heroku will just open up. It'll just fire off and launch a new dyno, and that PR will have its own isolated environment. It's part of their pipeline tooling, but basically that's what a lab is to us. It's an isolated environment that's just for that PR. Nobody else's code is going into it. And you know, we seed it with some kind of relevant data. And then there's, you know, staging, which is like a more shared environment. Still fake data, but you know, more relevant, more fake data. Everybody's kind of manipulating the database together, and you get a more realistic environment. And then canary deploys. Does anybody here do canary deploys? No? Does everybody know what the canary in the coal mine? Okay, so canary deploys are a practice you can also read about that a lot of people do. So the first when we deploy, the first thing we do is we lab deploy, then we stage deploy. And then when we're ready to actually deploy, we get in line and we go in the queue and we say, here's my PR, I want to deploy to canary. What that does is it spins up a few instances of Kubernetes in our case, and adds them into the load balancer and says, you know, 90% of the traffic is coming off of master, and then 10% of the traffic is going to your PR in these Kubernetes boxes, and the load balancer figures out to keep the traffic on the correct version. And then you let it run in canary for like 15 minutes or 20 minutes or however is the same amount of time for the PR depending on the type of change that you're making. And we have separate dashboards for canary so that we can see exceptions that are happening just on canary machines, performance problems that are happening just on canary machines. But this really kind of isolated environment where you're only sending part of your traffic. The nice thing about that is it's super fast to roll back. And if you do deploy a bug, it's a very limited portion of your traffic that's getting it. Once we've been in canary for long enough to be comfortable, and if all of our things are okay, like exceptions haven't increased and things like that, then we can do a full deploy. So we leave our code out of master and we deploy our PR to production. And then that runs for a significant period of time, again, depending on the type of change that we're making. And at that time, we monitor all instances. And then if things are good to go, then you can merge to master. And then we have an automated tool that updates all the rest of the PRs in the queue with the changes to master so that people don't have to do that manually. All right, so one of the keys to this working is...
One question on that.
Yeah.
Sorry. If you're running it deployed, if there's other changes that go to master, do those also go into that one? Would it work the other way?
I'm sorry, can you say
So
that?
you're saying basically a change to master, if you merge the master, it then goes and affects your PRs.
It affects everyone in the queue.
Everyone in the queue. If you're running and is it possible that something else would go to the master that would then interact with the thing here?
No, you can't deploy, you can't go to master unless you've been through the queue.
Okay.
Yeah. Yeah, that's not allowed. No one can merge directly to master. There's only, it's just not allowed. I don't know if there's an actual rule. It might be just a cultural thing, but it just doesn't happen. Okay, deploy consistently. So, all right, really the goals of this are to keep a running log of every change that has ever happened, and have just consistent deployment tools for everything. Making sure that everything goes through the same review process, that all changes follow the same automated pipelines, and we use Chatups for logs so that we have a consistent historical history of everything that's ever happened. Who knows what Chatups are? Cool. All right, we'll talk about Chatups in a little bit. We're talking about a lot. All right, consistency everywhere. So we deploy everything with a PR. We make DNS changes with the PR. We make Docker changes with PRs. We make Kubernetes changes with PRs. Security and access changes to any of our third-party tools go through PRs. Schema changes in the database, infrastructure updates, everything that isn't physical hardware is software in our company and requires a PR. Even security, like if I want to get access to Gmail, I have to open a PR. And all those things go through automated CI pipelines. They go through the PR review cycle, and they get deployed in Slack with Chatups. This is kind of mind-blowing. And when I started doing this, I was like, I don't even understand how this works. And I still to this day do not understand how all of it works, but I'll tell you, like, being able to go into Slack and being able to go into GitHub and search through PRs and history and see how everything has changed over time is so empowering. Because you never wonder, like, who did what, why. You just go look. And it really resolves a lot of questions and makes things much more secure and transparent. Yes?
How many people are we talking about?
At GitHub?
Yeah.
Let's see, when I started there were 425. Now we're 1,300, and we're supposed to hire 300 more in the next 3 months. And we have like another 600 or 700, I think, coming from Microsoft soon. I don't know. We're quickly approaching a couple thousand.
Thank you.
Yeah. One of the interesting things about this, we're onboarding 300 people in the next 3 months, and being able to do all of our security access changes in an automated fashion with a PR, we can do 300 people in like 2 hours and get them access to everything, which is crazy. Okay. We use Chatups to deploy everything, like I said. It gives you a log. It gives you a consistent deploy syntax. I didn't really think this was a big deal until I started doing it, but being able to go into any piece of tooling and say, how do I deploy this? Oh, I just say hubot deploy X to production, and it just deploys. And I don't have to think about it. Is so much easier than having to like read all these readmes and figure out how to deploy every individual thing. And it makes the process a lot easier. And the feedback that we have coming from GitHub is always the same, right? So when you deploy, it gives you a link to a monitor for exceptions. It gives you a link to a monitor performance metrics for that application. It gives you a link to where that application lives so that you can see it. And it alerts you if there are performance or exception increases automatically. And that consistency, I mean, we have hundreds of applications. That consistent process of always knowing exactly what I'm going to do and how it's going to act I can jump between projects very easily and feel like I know what I'm doing. This is a good blog if you want to read about our deployment process in more detail. And again, these slides will be in that repo. Okay, so what do deployments look like at GitHub? Our deployment process hasn't changed much since, like, I think probably 2015 or 2014. And some of it we've tried to open source, and some of it is like archived projects that people stop maintaining. So I'm going to talk about this. And then we're actually going to look at something that I've tried to throw together for y'all today. And we're going to try to live code something and see if it explodes in my face. But this is essentially kind of at a very high level how deployments work. So you go into Slack and you talk to HuBot and you say, I'm going to deploy this thing. It runs the GitHub checks API, hits the deployment API and says, hey, we're going to deploy this thing. The deployment API sends a webhook to this thing that we have called Heaven. And what Heaven is it's a very small wrapper around a bunch of shell, Capistrano, Fabric scripts that know how to deploy every application. So Heaven just parses out this deployment API hook. It looks for what you're going to deploy, where you're going to send it to. So I want this PR to go to staging, or I want this PR to go to master. It passes that information on to your deployment script of choice. It runs the deployment script, and then it responds back. It deploys the code, and then it responds back to HuBot with whatever you want HuBot to know about. In our case, where the dashboards are for that thing and the performance metrics. Yes?
Is having a substrate at Atmos?
Is it? Yeah, so I think Atmos was or used to be a GitHubber and built an open source version of our internal tooling, Heaven. It's no longer a maintained project. I was able to fork it and get it running on Heroku just by updating like the Ruby version and the Rails version pretty easily. But you can dig into that application and see what it is. There's like one controller and one route and like maybe a model. Like it's very small. It doesn't actually do much other than listen to a webhook, parse the webhook, run a script.
Yeah, almost like node mod.
Yeah. So there's not much to it, but it's a very powerful combination of tools. That's pretty cool. Here's a few different resources that kind of talk about this flow and the related things. So this old flow doc post actually tells a lot about how this process works. This is about what deployments are inside of the GitHub API. How many people know what deployments are inside of the GitHub API? Okay, so it's kind of a misleading thing. Like when I first knew about it or learned about it before I worked at GitHub, I thought like, oh, GitHub's going to deploy my code. But really what it is you tell GitHub you want to deploy a certain PR or branch. It creates basically the state saying, okay, you want to deploy this thing, and then it sends out a webhook to whatever your deployment script is. And you have to have an application that's sitting there that knows how to deploy it, and then knows how to respond back to the API and say, okay, it went okay, or it failed. And then GitHub just keeps track of which PRs are deployed where. So it's more like maintaining state than actually doing the deployment, and attaching that state to your PRs and to your branches so that you have it all in one place. Does that make sense?
Yeah.
Okay. Cool. So let's look at this GitHub Actions demo that I made and see how well this falls apart or works. Okay, so I built this little Rails application that's running on Heroku. Currently, there is no test page on production or on staging. Oh, actually, I'm supposed to pause for a break. Does anybody want to take a break? Anybody have to go to the bathroom or anything?
How long is the next stretch?
Probably a half hour.
No,
We'll go running? Okay. I just have your attention and you're all riveted. So we have these two applications running on Heroku that currently don't have a test page. I opened up this PR to add this very simple, whole new page inside of my application. And inside of this application, I have a few GitHub actions set up. So actions are currently public beta, I believe. So if you want to use actions, you have to like sign up for it. And then you'll get hopefully just immediately let into the program. But you will be otherwise soon. But what actions are they are these configuration files that you can create inside of your repo that tell GitHub to take some sort of action that you want to do on your code when a certain event happens. So it's kind of like a scripting language that's built into GitHub that can do essentially anything you can do with a Docker container or a JavaScript file. And on top of that, it encourages open sourcing these actions. So if someone else wrote an action and they open sourced it, you can just use it. So you don't have to write all of them yourself. So this is an example of a Rails CI configuration file. I start out by giving it a name, and then I say what events I want it to run on. So this is going to run on push and creation of a new pull request. And then I set up the jobs that I want it to do. So I'm naming this job test. It's going to run on the latest version of Ubuntu. It's going to have a few services. So if this looks familiar, it's because it's basically like a Docker file, or I guess a Docker compose file. And then you give it steps. So the first one here this is actually an action. So if I go to github.com/action, oops, that's not what I wanted. These are a bunch of like starter actions that you can just pull into your app and use. So the first one that we see is checkout at v1. So this checks out my GitHub repo and pulls it into the Docker container. And then I run a setup Ruby, and I get this action setup Ruby v1. So this is a shared action that just installs Ruby and all the things that I want to use in this Docker container for Ruby. I just give it the version that I want. And then I set up Yarn. And then I build and run my tests. So I have my Postgres and my Redis environment variables set up, and my Rails environment set up, and my master key. These are just environment variables that Rails needs in order to run. And then I say run this script. So that's essentially my test script at the bottom. So now every time I push to a PR inside of GitHub, this runs. I get this checks area inside of here that tells me whether or not it completed successfully. I can go in and see the details of the run. So this is how it set up Yarn. Here's where it builds and runs tests. So you can actually see all the output of that job. Yeah, so that's a basic CI script set up using GitHub Actions, and all of this is actually directly in your code base. It's actually just a part of this repo. So your test suite lives right alongside your code. And it's all version controlled, so you can see how it changes over time, make pull requests to change your workflows, etc. Also, if you want to edit this, we have like this kind of cool place where you can search the marketplace for shared actions and just pull in other people's actions automatically. Yeah, any questions about the CI part? Like a million? No? Okay. I must be doing an amazing job of explaining things.
Are you going to show how you actually hook in your repo to Heroku for like the continuous integration? Thanks.
Yeah. So when I push, this will run. It'll check all my code, make sure everything, all my tests pass. I could add linters here. Basically, any sort of script that fails with an exit 1 can be run as a CI job. So if you use like, I don't know, code linters or static analysis or whatever you want, if it's a Docker container runnable thing that exits 1 if it fails and exits 0 if it passes, you're good to go. Then I have this deploy script that I put together. So what this deploy script does, it runs on Ubuntu latest. It checks out my repo again. Like this is pretty boilerplate. And then I'm actually calling this deploy to Heroku stage. I kind of threw this together today quickly for this talk. But what it's doing is it listens for a deployment webhook call, and it says on deployment do this thing. It will check to see if the deployment environment specified is stage, and if so, it will force push to stage. Otherwise, if it's production, it will force push to production. And I just set my variables here. We do have secret management built into GitHub with actions. So in your settings page, there's a secrets tab if you have actions access. And it will encrypt and store your secrets for you automatically. And then you can access them inside of your code base. And as you can see, there's like variable expansion, there's conditionals, and then there's certain objects that we drop into the environment that you can code against. Yeah, so we do our force push to production if we want to deploy to production. We hit the deployment API and we update the status and say it was good or it was bad. That will then update the PR and put in the PR if the deployment succeeded or not. And then we reach out to Slack and either say success or failure. So this is, what, 66 lines of code, and it listens to Slack. Well, it doesn't listen to Slack. I'll show you how Hubot works. It listens for a deployment queue. It pulls down your code. It deploys it to the desired environment, and then it tells you in Slack what happened. You can clearly expand upon this and add more stuff. And also, this is all using off-the-shelf open source tooling. If you want to, you could, if you need to do more like sophisticated things, like basically if you can drop it in a Docker container or a JavaScript file, you can do it. And you can even pull in like the Okta client and have whatever's running in that Docker container interact with GitHub. So you could like write an action that listened for pull requests, pulled in the repo, did static analysis, and then commented back on the PR. Like you can make really kind of you can cross dimensions and kind of build whatever you can dream up. Yeah, so should we see what this looks like and see if I can actually get this to work? Okay, so we have this test PR. It's on this new page branch. I set up this Slack environment just for this purpose. And I put in the GitHub app. I don't know if anybody's used the Slack GitHub app, but it's kind of cool. Like it tells, yeah, it tells you like whenever someone opened a PR or when your tests pass, all kinds of stuff. But I digress. So let's try to deploy this to stage. So page. And this will take a minute, so bear with me. There's like a caching thing that you can put into actions to make them faster, but I didn't have time to like figure out how to do all that.
I was going to ask that question.
Yes. Yeah, you can cache all the like Docker builds and everything. Okay, so we have a new deployment request. So it says requested deployment to stage, and it's pending. So that has kicked off our action of deploy. So we can actually see it running here. And then it shouldn't say everything is done.
It looks like you need to click on deploy or what?
Oh yeah.
I don't know why it didn't just take it.
Yeah. I don't know either. It's going to the wrong thing. We're going to pretend that that's going to work. So this is basically the output that will come from that deploy job as it runs. So the green check marks are things that worked. The grays are ones that it skipped because the conditional didn't trigger. And so like here's me deploying to the master branch to Heroku. The other page that we have to look at, which is kind of hidden, and I kind of wonder if you have it. Let's find out. Deployments. There is this deployment page, which there isn't a link to anywhere that I'm aware of. But basically, it tells you all your deployments activity. So it can say like, you know, when things were deployed to production, when things were deployed to stage. You know that you have this pending deploy. And this is like a page where you can keep track of what's been deployed where when. And you can kind of filter it by environment. So every time that you set up a new environment, this will just add them to you for you. Issue key untied. All right. I want to see how I'm doing, but that link isn't working. Okay, so while we wait for that to work, let's just look up here at what this looks like when it actually works. So here we see I requested to deploy to stage and deploy to production. The GitHub app will actually the GitHub app ties into the deployments API. So if you're running the GitHub app, it will tell you, and you don't need to script anything yourself. This one down here is actually the action that I wrote responding. And as you can see here, I was able to add a little bit more information because I have more control over what gets posted to Slack. You can check out, oh my gosh, there's so many Slack actions in the marketplace right now. I think I counted like 15. But if there isn't one that fits your needs, like you can just fork it and write your own. But it's pretty cool to be able to post something to Slack after this automatic thing runs on your GitHub repo. Like, that's so powerful. Yeah. Yeah.
The deploy is showing as queued, which might be why you're not seeing any steps.
Oh, yeah. Queued. I want to run. Okay, well, I don't know how long it's going to be queued for. This is still in beta, just as an awareness thing. So there aren't necessarily. Oh no, I broke. Never do live coding. Yeah. So this is what it looks like. I do. I think I am support. And I actually just got an email from Slack telling me that it failed. Yeah. Boom, right there. But yeah, this is why you don't live demo things. Okay, any questions about all of this? That was a lot. How are there no questions? Yes.
So where to set up the environment? Is it in Heroku?
The environment,
Yeah.
as in
Different environment is in the GitHub or
different environments for what?
for deploying?
For deploying?
Yeah.
So I'm deploying to Heroku.
Oh,
Yeah,
yeah. So
yeah.
it's connected, so GitHub connected.
Yeah, I was just doing a git push to Heroku. So if you look at, let's look at the, if you look at this, so in order to do a Heroku push, you need your API token and then the app name that you're pushing to. And Heroku deployments are just git pushes. You just git push to Heroku with your credentials, and they run your stuff. In the marketplace, there's deployment actions for AWS, Azure, Google Cloud. I'm sure there's others. Also, if none of those fit your needs, like you can build a Docker container and drop a shell script or a Capistrano script or whatever your thing of beauty is into that Docker file and just have it run. And you can create your own private repos. So if you want to like share it among different applications, you can create a repo that just hosts that action, and then you can pull it into workflow files in different apps. And you just set like specify like environment variables to send into that action, so you can make it configurable. Does that answer your question? Yeah. Okay. Other questions about this? No? Okay, cool. Well, we're going to pretend that all that work didn't carry on. Okay, cool. So now we're going to talk a little bit more about culturally things. So I like to think of deployment as a team effort. I like the idea of deploying frequently by default. I mean, we deploy hundreds of times a day, and having that many people deploying at once just means that there's a lot of eyes on everything, because there's just so many people deploying at any point in time that people are waiting in line and they're just there and they're watching stuff, and there's a lot of people looking at the metrics and the performance pages because like your deploy might impact their deploy, so they want to make sure that like they're not going to get thrown off. So if you can like have this culture where there's like a lot of people deploying at once, it becomes safer just because more eyes is always better. And also like this idea of like deploying small things frequently, I feel is a lot safer, just because when you deploy huge features all at once, there's so many things changing in one fall swoop that it's harder to tell what caused a problem. Where if you're deploying like one small feature request at a time and doing things to kind of guard those that can be then removed slowly and later, you have a lot more control and a lot more visibility into what's happening with what thing. So I didn't start my career in this camp, but as I've done more of it, I've really come to see the value of like quickly iterating, deploying a lot, and having lots of people deploying in the same day, which I think is kind of counterintuitive. But it does create a culture of helping and monitoring, because everybody is just doing it all the time. So you just build these muscle memory around like what it's like to do this, and you know, there's just a lot of camaraderie that kind of forms. Make stats that are easy to share and access. We actually have Chatups where you can pull in very specific Grafana, Datadog graphs, and so I can say like .graph me uptime 5 days, and it will put into Slack a graph of uptime for our site for the last 5 days. And you can do the same thing with any metric we have inside of Grafana or Datadog. So CPU performance, RAM utilization, et cetera, et cetera, et cetera. And then train deployments. I talked about train deployments earlier. I think it's really good to get a bunch of people deploying the same thing on the same PR, just because then you have more eyes looking at things together. And I think that, yeah, we just deployed to stage. So we should be able to hit this now. Is it this one? No. Is it this one? Yes. Yay. I told you it worked. And I built all of that in like 4 hours today. So it's not, I mean, if you want something bare bones, it's not super hard to do. Monitoring while deploying. Again, it comes back to providing tools to see common issues. It also helps you limit the time that an issue is in production if you can make it easy to find. The worst bugs are the bugs that are there for a really long time. And if you can do anything to make it easier to find that stuff, like I don't know if people use Datadog, but Datadog has like anomaly detection, so you can say like performance is anomalously high, and it will use machine learning to figure out what an anomaly is for your particular running instance. But there's lots of ways that you can use tooling to automate monitoring, and you want to make it easy to share those sort of monitoring things. I think that if you have monitoring tools, you should just give everybody in the engineering and maybe even the company access to them, and don't like limit who can see what monitoring issues. Just open it up. Monitoring exceptions. There's a ton of exception monitoring tools out there in the world. You know, Honey Badger is the one that I took a screenshot of, but it's not the only one. Basically, what you're looking for in a monitoring tool is to make it clear where the error is occurring. You know, what URL, controller, endpoint, is it inside of a package? We actually have something that like it shows us where the exception is, and it shows us the stack trace. And when you click on the like stack trace output, it takes you to the GitHub repo where that code lives, so that you can see the code that's actually doing it. Who is experiencing it? So when you have things like canaries or labs or feature flags, it's important to know like who's experiencing this error, because it may just be a portion of your users, or it may just be in like one environment but not in another. So that's something to consider when you're pushing this metadata into these systems. You want to be able to roll up the most common exceptions. So you want a view where you can see this exception is actually happening 1,000 times every minute, so that you can get the noise out, right? Because I've never seen a system that doesn't have exceptions in it, because users always create exceptional behavior. The important thing is what are the ones that are happening a lot, and being able to identify those quickly. And also, if there is one that starts happening a lot, and it starts happening on a new deployment and it wasn't happening before, you want to push that directly into your chat ops in Slack or something, so that whoever is deploying sees it immediately, and they don't have to like dig through a bunch of tools to find it. Monitoring performance. I just threw up some common dashboards that I think everybody should have. There's a million others. I actually built a tool at work. It's a gem, and you can drop it into any Ruby application, and it hooks into the event system inside of Rails, and automatically monitors all kinds of stuff like controller response time, job performance, memory usage, et cetera, et cetera, et cetera. And it has a task that you can run from the command line that automatically creates dashboards inside of Grafana or Datadog, so that all of our applications have consistent views when you look at their monitors, right? So if you have multiple applications, if you can, try to keep like the language around what the metrics are similar, and try to keep the views that are shared consistent, and what the data in those views are consistent, so that when you jump from one app to another, you don't have this learning curve of like, what am I looking for? What are these things called here? That's just a lot of cognitive dissonance when you're trying to jump between different contexts. And the worst time to do that is when you're dealing with a performance issue, right? Because you're like already stressed out, and maybe the site's going down, and all of a sudden you have to learn a whole new dashboard to try to figure out what's happening. Automate alerting. Problems are not always caught. Again, with that tool that I wrote, we actually have some shell scripts that automatically create common alerts for different systems. So when you set this gem up inside of an app, you run a command and it sets up all the alerts that are common for all of our applications, and what sort of severity they are, how they should contact you, and then where they should link to inside of the graphing application. So that way when a common alert is identified, we know what it looks like, we know how to monitor for it, and we know how to solve it. So let's put that in a common place and share it with all of our applications. Slowly increasing footprints. We talked about this a little bit. This rolls into identifying issues with the smallest subset of users. Limit impact of releases until things are well tested. Validate solutions only with those facing the problem. Ensuring that rollback is easy and encouraging risks by limiting failure impact. As a developer, if you feel like if I make a mistake, it's not going to affect the whole system, you're able to take more risks and you're able to be more innovative, and you're able to try things. But when you're dealing with large systems and you're dealing with complex systems, and then you don't have good fail-safes in place, everything is scary. Again, deployment environments. Good canary rules. So coming back to the canary thing, this is actually covered in Martin Fowler's canary release blog post, but these are some good rules for creating canary systems. All right, changing data. This is a really big topic. I struggled with actually putting this into the talk because I don't feel like I can actually give it the breadth of coverage that's needed to talk about changing data. But I'm gonna take a risk and just cover some like high-level things. Don't throw me under the bus for not covering every situation because it is a really big topic. So some just good general practices are when you're changing data, try to be non-destructive. Try to make rolling changes. Deploy your code changes separately from your migrations. Allow for long running data changes. And then make things easy to roll back. Somebody's laughing. Have you made some of these mistakes? I made them all. Okay, so when you're actually migrating data, you always want to make a separate PR for the data migration than the code that you're making. And you want to run the migration prior to running your code changes. And the two should not affect each other. So they should be able to be mutually exclusive. They need to be backwards and forwards compatible, in other words. Because sometimes you need to roll back code, and sometimes you need to roll back schema changes. You need separate reviews for each. Oftentimes the database team, if you have such a thing, cares a lot about how data is going to be migrated, and the code team cares less. So if you just push your migration changes through a team of developers, they're going to be like, looks great. And then the database people are going to be like, this is crap. And you're going to be like, ugh. And I know like we have a lot of like rules about how we can migrate data, because we have such a complex data environment. If you're dropping columns, there's a lot of tools to help you ensure that nothing is utilizing the column. So you always want to get your code to a place where nothing is using that column and then drop the column. And if you're not using a column, it's probably okay to like let it sit for a while, and just be sure. But like New Relic has stuff and MySQL has stuff. There's a ton of tools out there to figure out if anything's accessing a column. And then ensure all the indexes you need are present. This is kind of magic. Indexes are notoriously hard to write well, and they're notoriously hard to know when to write one. So like that's why things like slow query exist in MySQL. But if you want to learn more about indexing, I recommend SQL Performance. It's a really good book that covers all the algorithms that SQL uses for indexes and how they work. And it's like 100 pages or something. But there's a ton to know about how indexing works. I'm not going to talk about all of it, but make sure you have them all. Okay, rename a column. So if you're going to rename a column, I recommend actually not renaming it, but creating a new column with the new name, putting some code in place that double writes to both columns at the same time, and then write a transition to copy the old column to the new column. This can be a long-running script, because since you're populating both at the same time, you don't have to do it in a hurry. And then once everything is staying in the expected state, then it's okay to drop the old column. There's a lot of tools inside of your ORM tools if you use one to alias methods. So one way to ensure that you're no longer using a column is to take that model that you're using and then alias the old name to the new name. And you should override the previous attribute. If you're not in Rails or Go, I don't know what to do. Go see your ORM specialist who isn't me. Data transitions. Data transitions are separate PRs from data changes or code changes. They have to run in the test environment just like everything else. You want to be aware of altering or moving data. Jumping back to running in the test environment first. This one is interesting because sometimes your code paths change. And that's the thing that you want to prevent, right? So that's why renaming columns shouldn't happen, and moving data from an old name to a new name should happen, right? Because you want to separate those code changes from your data changes. If you run your data change through the test environment and your code fails, then you know you have a problem. Add your indexes. Use MySQL batches instead of trying to update everything at once. If you're moving a lot of data, MySQL offers batches to help you do that. And it's a lot faster, and you can utilize those MySQL performance gains. If you're doing a large change, set up some read-only replicas so that you're not hitting the database that's being written to a lot as frequently. You want to try to create a dry run transition to check state before running. So a lot of times we'll put like a no-op command in front of a data transition, and it'll list out what it's going to change if you have that flag but not actually change anything. Or it'll dump out the SQL command that it's going to run. You want to add logging because you want to make sure this thing doesn't die, or if it's running for a long time, you want to know where it is in its process. Because sometimes shell scripts fail or something. And then write a test for your transition because testing everything. All right. Ultimately, deploying is a feature. So questions you should ask yourself is, who owns this process? Does anyone in your organization actually own deployment? Or is it just kind of ad hoc, whatever goes? What are your best practices? How do you enforce consistency? How do you make consistency easy? How do you enable quick access and action in the case of a bad deployment? Is your process blameless? What repetitive tasks can you automate? And what one thing can you do to feel more confident? Oops. You did something wrong. Remember that availability is the best ability. Redeploy master. We do have a concept of revert PRs in GitHub, so if you merge to master, you can go into a PR and hit the create revert PR button, and it will create a PR that undoes what that PR did. Make non-destructive data changes. Back up everything. Run blameless retros. Who knows what a blameless retro is? Cool. So a blameless retro is a tool for sitting down as a team, looking at what happened, and talking about it without blaming anyone. What was learned and what can you do better? And you are responsible for the mental health of your team. Try to be kind. Try to understand that this is difficult for everyone, and try to help each other do better in the future. Thank you.